Law of cosines work through, guys, come on. We use the law of cosines when the law of sines doesn't work. When you have law of sines, you are using that whenever you have an angle and the side opposite. That's when you use law of sines. You're going to use law of cosines when you don't. Okay? Now, I'm not going to lie. Law of cosines looks very weird. Takes a little bit of time to get used to using it, but it's no more work than this. It really isn't. It just looks weird. So law of cosines versus law of sines. Law of sines. Bless you. Okay. Law of sines. Guys, enough. Enough. Law of sines. You use it when you have the angle and the side opposite that angle. That's what you use over and over again to simplify and solve out those ratios. We use law of cosines when you don't. Okay? So, when you're using law of cosines, the easiest thing to think of is when sines doesn't work, or if you have those two. What happens with law of cosines? If you happen to have two sides and the angle between, you won't have the side opposite. Or if you have all three sides, you don't have an angle, obviously. So if you wind up looking at a diagram, it's very, very easy to tell if you have this scenario. It's very easy to see that you have the angle and the side opposite. When you have side angle side or side side side, that just means that you have 3, 17, and 4. That's what that would be. You have an angle, but you don't have its opposite. Or you would just have all three side lengths. Okay? It might look like that. What happens here is that the law of cosines will look very weird. It takes a little getting used to how it's written out. Just like law of sines. When we had law of sines, do you notice how there's 3 different ratios? Sine of A over A, sine of B, and so on. Law of cosines kind of has the same idea. There's 3 different ways to write it out. Let me show you. Hold on. Take a deep breath. Take a deep breath. No, it doesn't work at all. Hence the sign. When you have law of cosines, yes, it looks, gee, well, I'm messing with you. I'm messing. I want you to notice this. See how it begins with a side and it ends with the angle opposite that side? That's what the law of cosines looks like. It's going to force you to find a side opposite of an angle, or an angle opposite of a side. That's what it does. When you use law of cosines, you only have to do it once, because immediately you can go back to law of sines. So there's 2 other ways to write this out. And notice all I'm doing is rotating the letters. And, and like I said, yes ma'am,
What's this equation for?
called the law of cosines. And like I said, it just takes a little bit of getting used to. Whenever we do like quizzes or tests or even on the final or whatnot, I'm never gonna make you guys memorize law of sines or law of cosines. I will always give you that formula. I'm not gonna tell you when to use it, which one's which, but it's pretty obvious which one you use a sine with, which one you use the cosine with. I hope you've noticed the letters. But it's a matter of knowing when to use them, okay? Law of sines, if you have the angle and the side opposite. Law of cosines, when you don't, okay? Let me show you an example of what this is gonna look like. So we have triangle ABC. We have triangle ABC. You're given angle B. We know little a, and we know little c. What is this one forcing you to find? You know angle B, side B. It's forcing you to find side B. The reason that it's forcing you to side B is because you have the angle B. So if you have the angle B, that means you had to have sides A and C, which forces you to find that side. So of these three versions of the formula, which one are you going to use? The second one, the one with the b squared and the angle B in it. So what we do is this. We write it out, just like we have before. B squared equals a squared plus c squared. Do you know what a is? Do you know what c is? Do you know what angle B is? So don't you know everything to substitute in? Yeah. Question. Now, if you look at that, it looks awful. But is it just going to be some number equals b squared? Are there any variables on the right-hand side? No. You type it right in the calculator. You go right to the calculator and type it in. Exactly the way you wrote it. 45 squared plus 43 squared minus 2 times 45. I've typed it into my calculator exactly the same way that I wrote it down, which is what you're supposed to do. This is what we've been doing all along. You hit enter. That number equals b squared. This number now, how do you get b by itself? Square root it. So back to the calculator then, b is going to equal the square root of that number. Square root of your answer. It's straight calculator work, guys. It looks awful, but it's just pressing buttons. It's just pressing buttons. Okay. So now if you think about what you have, you now have a side opposite an angle. Once you have that, what do? Yeah, you use law of sines then. You only ever have to use cosines once, because it'll automatically find you the other side or another angle. Okay. Can you guys stop talking, please? All right. Cosines looks awful. It's a lot of buttons to press, but that's all it is. It gets you a side right away, and then automatically you can dump and use law of sines. There are a lot more rules to this that we talk about in Algebra 2, but for us, it's all we need. It works. Okay, for us right now, it's all we need to worry about. Let's try it again. Oh, I forgot it. Yep. Yeah, you only ever have to use law of cosines once. After you use it once, then you can go right to law of sines. No, tonight we're just going to do cosines. I want you to get used to using cosines first, and then we'll mix it all together. What I'm looking at doing is that there's no reason for us to do this all 4 days and then give you guys a take-home. We're just going to quiz on this on Thursday. Then be done. That way you don't have to worry about doing anything over the weekend. Okay? Yes, ma'am. Okay. All we're doing tomorrow is we're going to take the cosine and just do one more, and then finish it out with the sines. So if you're okay with law of sines, once you do this a couple times, then you just switch to the sines and you're done. All right? Look at it. There you go. Okay. Yes, sir. What do I do now?
Draw it out.
Draw it out. Right. Draw it out. Come on, guys. Way too much talking. Okay. Draw it out. Label it. Figure out what you have to use. Do I have an angle and its side opposite? Nope. Which means I can't use law of sines, which means I have to use law of cosines. Which angle do I have? A. So what side am I going to have to find? Little a. Write it out. You now have every piece of information to fill in the blanks on that whole equation on the right-hand side. Okay? You have all the info. Little a squared is 17 squared plus 30 squared minus 2 times 17 times 30 times the cosine of 28. That is a long string of some crummy numbers. But as you put them in the calculator, it's going to look exactly like you just wrote it out. It looks the same. We hit enter. And that number equals a squared. What do you have to do then to get a by itself? Square root. Are you guys getting accustomed to hitting that second answer button now?
Yeah.
It's such a nice little trick to have. 1698. And there's your side. Okay. So I know a couple of you guys have already said that you're not going to be around tomorrow. What we're going to do tomorrow is just take this the next step. Once you find out that you have that little a at 1698, now you would use law of sines to either figure out angle C or angle B, and then you just subtract to get the third angle. It works out being a problem like you did yesterday. If you did those, fine. The cosine ones take so long. Now, what happens if you don't have an angle? That's where this gets weird. Filling in the blanks straight across and just taking a square, it's easy. But sometimes you have this. Sometimes you have this, where you don't have any angles. Now, with the law of cosines, if you don't have an angle to start with, there's only one rule that I need you guys to follow. The one and only rule if you need to find an angle first, the side case, find largest angle the only rule that I can tell you about law of cosines that you need to know for right now is that if you guys have to find an angle, the side case, when you have to find an angle, the only rule that you have to follow, you have to find the largest angle first. The reason that is because in Algebra 2, when we talk about law of sines, there is a possibility, given certain parameters, you could create multiple triangles, or you might not be able to create a triangle at all given certain information. Same thing goes with law of cosines. This, if you can make multiple triangles, when it's called the ambiguous case, because sometimes weird things happen in math. Law of cosines, if you find that largest angle first, you're basically alleviating the issue of ever having to worry about multiple triangles when you switch to law of sines. It's a little trick that we teach in Algebra 2. Obviously, you guys need to really worry about that now because you're not have to come across that issue. But in a year from now, or a year and a half from now, or whatever it's about a year when they start talking about trig in Algebra 2, you might have this little thing in the back of your mind going, oh yeah, Murphy did say something about that. He's not a total crackpot. Thanks. Not crackpot. Crackpot is like, like a total doofus. Small doofus. It's not total. It's like 20%. Well, but I'm not 80%, I'm not a doofus.
No. Wait, no.
So for right now, I'm not going to worry about solving the whole triangle, but in this example, which angle is it forcing you to solve for first? Yeah, which would be the largest angle here? B. Remember, the largest angle is always across from the longest side length. So if 6 is the biggest number, the angle across from the 6 is angle B. So that means I'm going to use the B equation. Okay? Before I get into that, I want to remind you guys of something. (15 equals 18 plus 3 minus 2x squared). If you were to solve this equation, what would you have to do first? Combine like terms. Good. In this case here, you have to combine like terms. Okay. What's 18 plus 3? Okay. Then what would you do? Move the 21 by how? Good. I would subtract the 21. And I get negative 6 equals negative 2x squared. Now what would you do? You divide by the negative 2. And you get 3 equals x squared. What did you do then? You square root, okay. And you get the square root of 3 is x, or plus or minus if you want to get real fancy. Okay. You've solved a 1, 2, 3, 4 step equation before. right? Okay. Now watch what happens here. It's the exact same thing, but they put the word cosine in it. Fill in the blanks. You get 6 squared is 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of angle B. Go back to the generic equation we wrote here a second ago. What was the very first thing you did? Combine like terms. The only like terms that you can combine over here is 4 squared and 5 squared. What's 4 squared plus 5 squared? 41. So this becomes 36 for 6 squared. Can I multiply these together?
Yes.
2 times 4 times 5. Shh. Come on, guys. Okay. Notice you are here now. You combine like terms, you multiplied stuff out. Then you moved here, you moved the 21 over. What am I going to move there? 41. How? What's 36 minus 41? I can't, because that's got a variable thrown to it. Can I combine these two here? Treat it the exact same way. You treat it the same way. That's why I wanted to show you that example. It's the same thing. So you get negative 5 is negative 40 times the cosine of B. How did you undo multiply here? How do you undo multiply there? Divide. Same process. Now this fraction then equals the cosine of angle B. Which means whenever you're trying to find an angle, what button do you have to press on the calculator? Inverse. Go to the calculator now. You've done all the work. 5 divided by 40 gives you the decimal. That ugly decimal equals the cosine of B. Second cosine of your answer. You just inversed it. There's your angle. When you're solving for the angle in a cosine problem, it's the exact same thing like I showed you here. The only thing that changed, instead of taking a square root at the end, I'm doing the inverse cosine at the end. Everything else is the same. Nothing changes. Whether the numbers are smaller like this, or they're larger like the next one I'm going to show you. You do the same step-by-step process. It does not change, nor will it ever. You just have to get the understanding that when you're solving equations, you're doing the same process. Combine like terms, and you do PEMDAS in reverse order. That's all you do. Okay. Let me show you another one. Oh, but then notice what happens here. If you have 82, 82 for your angle B, see how now all of a sudden you have an angle and its side opposite? And then you go right back to law signs. There's no reason to continually use law of cosines. It takes too long. Signs are quick. No. There's no such thing as the law of tangents. People have asked that as well. There's nothing like that. So, let's try another one. Yeah, right. They're all big change the letters. Okay. We'll change it up a little bit here. Once again, I want you to notice that this is that side, side, side case where you have all three sides. This is the time in which that you have to solve for just one angle to start with. But you have to make the decision as to which angle you're going to use. C. C, que bueno. So which of the three equations are you going to use? The c squared equation. Write it out. And then, once again, you fill in the blanks. We know that here's a little a, a little b, and a little c. So, 27 squared is, excuse me, 23 squared plus 16 squared, 2 times 23 times 16 times the cosine of c. Once again, you're going to combine your first two parts together. You just use the calculator. You'll figure out what is 27 squared, what is 23 squared plus 16 squared. You type that in the calculator. What do you get for 27 squared?
75.
7 what?
85.
For these two put together?
Yeah.
Okay. What do you get for 27 squared?
79.
Thank you. And then you have to multiply these three together. 736. It's still the exact same multi-step algebra problem. It just so happens it has bigger numbers. That's it. Processes don't change in algebra or in math whatsoever. The only thing that changes are numbers. You still go through the exact same process each and every time as you go through the problem. So what's your next step then? What do you move first?
The largest numbers.
The 785. Good. How do you move the 785? Good. Subtract the 785. 729 minus 785 is?
756.
Thank you. Now this has to equal negative 736 times the cosine of c. These two are being multiplied together, which means you have to divide. And now at this point is when you go right to your calculator. You divide it out. You'll get some crummy decimal. That crummy decimal equals the cosine of c, which letter we're working with. Okay? So press the buttons. Second cosine of your answer. And there's your angle. 8564. Jeez, and you're wearing glasses?
These are old glasses. I'm getting new ones tomorrow.
Okay. Hey, if there's one good thing about getting older, your eyes don't change after a while. My prescription for my eyes have not changed in 20 years.
Yeah, I got new contacts, so I didn't get new glasses.
Yeah, I hate insurance because of that. You get one or the other. It's a racket. Eye care is just. It shouldn't be so expensive. Yes, ma'am. Yeah, oh, yes. Right. Thank you. And then there you go. Okay. What happens here, guys, is that you're going through the exact same process each and every time. It's just a matter of which part you're trying to find. Okay. Let's see. Which of those is going to be the largest angle? Find it. Take a second. Find it. We'll see how you did. All right. So you guys are all okay that you have to find angle B, right? Because it's the longest side length. So 18.4 squared 12.9 squared plus 15.6 squared minus 2 times again, it's just ugly decimals you gotta press. All right? Four. One more. Hey, can you guys just take a picture of it real quick?
Mr. Murphy, what numbers are we doing?
Series by
I can't believe I'm missing. Hey, do me a favor. If you don't have a sheet, take a picture of somebody's real quick. I didn't realize I didn't run off enough of them. We'll come back to this one later because I know we're running out of time here. On the study guide side. Okay. I want you to do number one. Oops. Find little c. We're not solving the whole triangles here. We're just going to use log cosines once for 4 different problems. Number 2, find little b. Number 4, find angle c. And then on the other side, it's number 5. Also find angle C. Okay? So if there wasn't enough of those as they went around, I didn't realize I missed some. I have, who's this that I saw? Yeah, just those, just 4 of them here, and you're not solving the whole triangle. You're just gonna find, for one of them, find one side. What I'm basically asking you guys to do, guys, come on. What I'm asking you guys to do here is use the law of cosine 4 times, 1 for each problem. Okay, and that's it. All right. No, we'll do that next time tomorrow. Yes, ma'am. What is that for that problem? Oh, I haven't done it yet. Did anyone else get a picture? I apologize, I ran out of. I want to steal this one and no. What's that? You see? Did you read this was still a negative here, okay? So this should still be a negative here.
Oh, yeah, it is.
Okay, so you did type it? All right, okay. Yeah, if you find it out, do that. Sure.